interesting in this whole thing is games are called game. Like, is anybody a gambler? Like, I'm not at all, so I don't know a whole lot. But in favor of the player, in favor of the house, or a fair game, all comes down to expected value. So if you do expected value and your expected value is negative, that's a game that's called in favor of the house, meaning the casino or the dealer is expected to win and you're not. So most games are like that, where you're most likely really going against the odds, and you're going to lose money. Games that are in favor of the player are where if you do the expected value is positive. I know I'm like an 80-year-old woman, but I am obsessed with Wheel of Fortune. Does anybody else like Wheel of Fortune? Okay, so Wheel of Fortune is called in favor of the player because no matter what, even if you don't win, you walk away with $1,000, right? So no matter what, your expected value would be positive. And then a fair game is when your expected value is 0, okay? So you have the same chance of winning as you do losing. So that's just kind of some information. It could be extra credit or something like that. So in favor of the house is a negative expected value. In favor of the player would be positive, and a fair game would be 0. So what do we want to know? We don't really want to know mean, but we want to know the span. Like, okay, yeah, they take 2.94 classes, but is that really spread out, or is most people right around that 3 classes? So we can figure out standard deviation, okay? The formula looks pretty crazy, okay? So technically you'd have to find variance first. So this is population variance. If you were to do it by hand, I would use this formula if you were doing it by hand. Because what this formula is, it's basically the formula we just did with mean. Instead of multiplying x times p of x, you just multiply x squared times p of x. And then at the very end, you subtract your mean squared, okay? So it's not horrible to do by hand. Again, when I taught this class when I first started teaching, and calculators were not required, we had to do everything by hand. So that I would pick that over the top one, okay? But we rarely want variance. We want standard deviation. So there's standard deviation. He's just the square root, okay? So guess what, guys? I'm not going to even have you do this by hand. We already know how to put it in our calculator. So again, same question. We have the random variable x that represents the number of classes the student takes. We want to know, we know the average is 2.94, but is that a compact 2.94 or is that a really spread out 2.94? So let's figure out the standard deviation, okay? So we'll do standard deviation x. That will be the standard deviation. And then I'll remind you, how do you find variance after that, okay? So we'll just put it in our calculator. I already made you delete it. I didn't mean to do that. That was not my... So we're going to have our list cleared out. And in list 1, we put our classes 1, 2, 3, 4, and 5. In list 2, you always put the corresponding probabilities or weights. And you're going to do a stat calc 1 variable stats, but again, you have to tell it to look at list 1 as well as list 2, because if not, it'll just average 1 through 5, and it won't take into account those different weights. There's no guessing, guys. They don't even give you an S. Sigma is the only standard deviation they give you. So this is 1.27 classes. Bless you. All right? So a problem on the homework might ask you to find all 3. What's the mean? 2.94. What's the standard deviation? 1.27 classes. But then it might ask for your variance. And honestly, guys, variance is not really needed. We don't really use it. But if you were doing it by hand, you would have found variance first and would have taken the square root. So remember, in order to find variance, we need a square, but we need to square a good amount of decimals, okay? So we're going to take 1.271377 and square it. Remember doing that? I think we had to do that in chapter 3, where standard deviation, our calculator knew that we had our standard deviation right here, but variance was the square of that. So grab 4 or 5 decimals, try to be as more specific, the better. So 1.271377 squared, rounded to 2 decimal places, you get 1.62 classes squared, which is kind of a weird unit, but that would be your answer. So standard deviation is really what we want. Variance is just going to be part of the question, because if you were doing it by hand, you'd find this first, and you would take the square root and get 1.27. Don't forget about what standard deviation means. What's standard deviation mean?
How far off it is from the mean.
it's how far you off from the mean. So on average, what is the spread of our data? So our mean was about 3 classes, give or take a little more than a class, which makes sense because we only range from like 1 to 5. So I knew our standard deviation wasn't going to be that big there. Okay.